What up, Precalc? Let's do the review. We're writing vectors as a linear combination. We use I and J for X and Y. We use K for like the Z third dimensional component. So this is just one I plus two J's minus root three K's. If there's no I's, you don't put I. You just have four J's plus a K. This would be negative two I's, no J's, plus 17 K's. Component form, it's probably easier to understand. It looks like coordinates, but it's not a vector 4, -5. In standard position, has the coordinates 0, 0, and 4, -5, but that vector can be anywhere, and we'd say it's equivalent. -6j means you don't have an x component, you just have a y component. Here we have an I, we have a j, and we have a k, so we need three-dimensional components. X has an initial point 416 and a terminal point 1006. So this is great. This is a situation. We have a vector that's not in standard position. What is its like vector component form? Well, you got to like figure out, how much is the x component, the y component. It's probably easier to look at this like two dimensionally. If I give you like the point 23 and the point 57. Okay. Well, like, how do I find this vector's x component and y component? Well, you just got to find this x distance and the y distance. You just end up subtracting, like, this is 5, this is 2, in between it's 3. So that's the x component of the vector. This is 7, this is 3, 4. It's a perfect example. So subtract the x's, 6, there's your x component. Subtract the y's, -1. This is its initial point. This is its terminal. So like initial terminal, you just take your terminal minus initial. Terminal minus initial. 6 minus 6 is 0. There's the linear combination, or there's the component form, and here's the linear combination. There's no k, so you don't need it. Finding magnitude. This is where we like break out our friends the right triangles. Put your V in standard position, 1, 2, boom. How do you find a magnitude? How do you find this length? Well, you got your friend Mr. Pythagorean theorem. This is 1, this is 2. 1 squared plus 2 squared is 5. Square root that, root 5. Uh, this is interesting, just -6j. That might seem confusing. It's like, how do I use the Pythagorean theorem? Well, it's like, if you're just going down 6, that's your magnitude, it's 6. I wouldn't say it's negative. Magnitude is a length. And then we talked about in class the Pythagorean theorem in 3 dimensions, where it comes from. It's like, well, it's got x squared, y squared. It gives you the kind of the two-dimensional magnitude. And then if we go up into a third dimensional, we take that magnitude and the distance going like out of the paper, and it ends up just being the Pythagorean theorem just with an extra dimension. You are not given that formula. Okay. I will show you the formulas that you will be given shortly, but you won't be given any of these formulas so far. So I got 16 plus 16 plus 49. I'll just use my calculator for that. Is 81. Oh, look at that. Square root of 81 is going to be 9. All right, so that's the magnitude of the. Okay, finding unit vectors. You're not given the formula for finding a unit vector, but we remember, and I'm going to use the example with 3, 4, what it visually looks like what we're doing. Let's say this is the vector 3, 4, and I want to turn it into a unit vector in the same direction. Well, what do they have in common? They have the same direction. Okay, cool. So the angles are going to be the same. only this vector needs to have a length of 1. That's what it means to be a unit vector. Well, I need to kind of convert this. Well, this can be found, the magnitude of this vector is 5. Well, I need to turn the 5 into a 1. What it is a dilation, like you did in geometry. You will divide or multiply all of your lengths by a certain value so that you can convert to like these are similar triangles. All the things are going to be proportional. So to take 5 and turn it into a 1, I'm going to divide by 5. I'm just going to take all of my components and divide by 5. So I get that the x component will be 3/5 and the y component will be 4/5. The same happens everywhere. And what did we do? We took the vector and we divided it by the magnitude. That's how you create a unit vector. There's the formula. And if you want to memorize it, great, but probably better to understand it. Take your vector, divide it by its magnitude. The magnitude of this, 1 plus 3 is 4. Square root is 2. So the unit vector, I don't know how to put unit vector. I'm just going to write unit v. So 1 squared plus negative root 3 squared, square rooted. 1 plus 3 is 4. Square root of 4 is 2. Will be 1 divided by 2 and negative root 3 over 2. We're familiar with that. Let's say, what is that? Over 1/2 down negative root 3 over 2. It's at 5 pi over 3. 2i, that's just 1, 2i. Well, 1i, I mean, I can just kind of figure that out. That's not very hard. If it needs to be a length of 1, take 2, make it 1. There's no angle going on here. Same thing here. Let's find the magnitude, and we'll take, maybe it's tough to see here, but if we find this magnitude, we'll divide by that magnitude to make it a vector of 1, length 1. So we need to find the magnitude here. 16 plus 16 plus 49. Like we're working with the same ones here. So the square root of that is 9. So I will take all of my components and divide them by 9. All right, how do we find these directions? Now, it looks like we're set up so that I'll take it.
Have a nice weekend.
You too. So that we don't need to use a calculator. You're able to use a calculator on everything, so I might as well throw an extra one, like 3, 4, because I can show you how to do it with and without a calculator. All right, we got this vector -2, 2 root 3. It's very important to understand what quadrant we're in. We're in the second quadrant. So this is -2, this is 2 root 3. Now, we can use our friend, the right triangle, and we could set up a formula using SOHCAHTOA. I could say tangent theta equals opposite over adjacent. Okay? Now, you could do this without a calculator. Tangent theta equals, if I have 2 over root 3 divided by -2, it's like times -1/2, you get -1 over root 3. And you guys should be able to answer this question. When does tangent theta equal 1 over root 3? You know that there's two options. It's either the tall 30, 60, 90 or the short 30, 60, 90. Which one, where we take opposite over adjacent, do we get 1 over root 3? This is going to be the 1. 1/2 over root 3 over 2. That's going to give me the 1 over root 3. This short 30, 60, 90 triangle occurs at the 30-degree reference angles. Those are the pi over 6s. So I want the pi over 6 in the second quadrant, or I want the 30-degree angle in the second quadrant. So that's 150 degrees. 150. Let's use our calculator. get 150 the other way. Uh, I will take tan inverse to solve for theta. So theta equals the tan inverse of negative 1 over root 3. Tan inverse 1 over root 3. And I get 30 degrees. It should be negative 1 over root 3. Make sure you're in degree mode. Answer's not negative 30, right? This is where, like, using tan inverse, you're either going to get an angle in the first quadrant or a negative angle in the fourth quadrant. But you got to know, okay, this vector is pointing in, the second quadrant's direction. So that angle is a reference angle. And it's like, oh, I need 30 degrees away from 180. Boom. That's how I'm going to get 150 with my calculators. Take the 180 and, subtract that 30 or add that 30. Okay, two different ways, but you'll be able to use your calculator on the test, so it's fine. This is the same thing. I'm going down over to the left, root 3, down 1. So we're in the third quadrant, so we're going to be somewhere between 180 and 270. I could set up the formula tan theta equals opposite over adjacent. So that's going to be tan theta equals 1 over root 3. We just did that. We just found it's at a 30-degree reference angle, but this time it's going to be in the third quadrant. So that's 180 plus 30 degrees, which will be 210 degrees. Could we find this with our calculator? Yes. We would do the tan inverse of 1 over root 3. My answer's not 30 because I know what quadrant I'm in. I'm in the third quadrant, so there's my reference angle. Add it to 180, you get 210. One, two. Again, you could do this both ways. 1, 2, 1, 2. Actually, you can't do this both ways. 1 does tangent equal 2. I hope we're all getting hundreds on this quiz. And that we don't need to help each other because it's actually a very easy quiz.
I forgot how to read that.
Yeah. Hi, JK. Yeah. Okay. 1, 2. We would have to set it up tan inverse of 2. Tan theta equals 2 over 1. I don't know what that is, so we will have to use our calculator here. I thought we didn't, but we do. We are fortunately located in the first quadrant, so I don't have to manipulate anything. 63.43 degrees. But be careful, depending on what quadrant, take your angle, make sure you move it based on 180 or 360 and kind of go from there. Like we haven't done a fourth quadrant one yet. Why don't we do a fourth quadrant one yet? 3, negative 4. Okay, 3, negative 4 for fun. To the right, 3, down 4. So I'm there. What's this angle? Tangent theta equals opposite over adjacent. You would take the tan inverse of negative 4 over 3. That's not my answer. We're looking for 0 to 360. That'll be expressed in the question. Give me an answer between 0 and 360. So we know it's 53 degrees away from 360. I'd add it to 360. So just be ready for that. No matter what quadrant you're in, you can handle it. Okay, if this is so polar, this is polar. Like literally the last unit we did before the break, we are doing these things. So this is a perfect unit. Vector's got a length of 2 and an angle of 240 degrees. I could do this without a calculator if I wanted to. 240 is 60 degrees away from 180. So that's 60 degrees. This is a length of 2. What do I do? Well, it's like I need to find this x. I need to find this y. Well, it's a right triangle. SOHCAHTOA is the formulas we can use. Pythagorean theorem can be used. SOHCAHTOA works out better because we have an angle. So we know like the sine of that angle, or you can do that 60 degrees and just make sure to pay attention to the direction, equals opposite over hypotenuse. Boom. Your y coordinate is going to be 2 times the sine of 240. We know that the cosine of that angle is equal to the x over the hypotenuse. Boom. 2 cos 240 is the x. This is polar. This is r, though it's like magnitude. Cosine theta is x. R sine theta is y. Or you could do like magnitude cos theta. This formula is not given to you for your test. Here are the only formulas given to you for your test. I'll show you. These. This is it. You will be told, here is dot product. Here is projection. Though the projection formula may be a little bit different. They might have the a squared here, and they might have like this up there, or dot product up there. Okay? Um, that's it. The rest you need to know from your knowledge of triangles. So you aren't given this. You should figure that out. You're smart enough to do it. So the sine of 240, we know. The sine of 240 is the sine of 4 pi over 3. It's the vertical. It's negative root 3 over 2. So this is 2 times negative root 3 over 2. And then the cosine of 240, the adjacent is negative a half. So this is 2 times negative a half. So I get negative 1 comma negative root 3. Those are my forms. Let's say you had your calculator, you would simply do 2 cos 240, negative 1, 2 sine 240, negative root 3. Don't believe me? That's it. Okay? So good question because you can do it without a calculator or with. A lot of vectors here, and then we're going to be manipulating them, including some dot products. You want to sketch them. I don't really want to sketch them, but let's do it. 0, 2. There's a. I'm going to skip sketching them if you guys are okay with that. I honestly need to like copy them and paste them over so that I can see all of them. Let me get a copy of this. All right. A plus D. To be honest, like the visual of adding vectors is cool. It's not necessary though. Like you could say, okay, A is the vector 0, 2, and then B is the vector negative 2, 0. So I'd go to the left, and then this would be the vector A plus D. Great. But literally just take your X components, add them together. Take your Y components. Oh, sorry. 0, negative 2. Gosh. 0, negative 2 would mean I'm going up 0, 2, and then I'm going back down 0, 2. I end up with a vector of 0, 0. Take your X components, add them together. Take your Y components, add them together. 0, 0. C is 2, 2. H is 2, negative 2. So you're going up and to the right 2, 2. And then you're going to go up 2, but then down negative 2. So 2, negative 2 is right and then down. So you're going to end up there. So boom, there's my C plus H. That's the visual of it. Is this necessary to do? No. 2 plus 2 is 4. 2 minus 2 is 0. Boom. Like that's how you can see it. Magnitude of C is 2, 2. So we use the Pythagorean theorem, 2 squared plus 2 squared, square rooted. 4, 8, square root of 8. Maybe make that 2 root 2 just to be safe. Okay, dot products. Multiple ways to do dot products. First way, it's probably the way that you're used to, is to add the products of your x components and your y components. It's the work being done. The other way is to take the magnitude of b, the magnitude of d, and then multiply by the cosine of the angle. This is a very important formula because it shows that if theta equals 90 degrees, the cosine of 90 degrees is zero, the horizontal is zero. Since the cosine of 90 is zero, the dot product zero. That's the most important thing actually you're taking from this unit is things that are perpendicular, we call them orthogonal, their dot product zero. That is used often in Mr. Huffaker's multivariable calculus class. This is Mr. Messner. Hi. Hooray. Oh, they're in the mailroom? Great. I appreciate it. Thank you so much. Bye. Um, so let's look at this with B and D. So B is negative 2, 0, and D is 0, negative 2. I know immediately that these are perpendicular. Watch what happens. X times X is 0. Y times Y is 0. The dot product 0. I also know that between negative 2, 0 and 0, negative 2, the angle between them is 90 degrees. If I did magnitude times the cosine of 90 degrees, it's another way of getting 0. These are easy. I don't like the numbers that we use. They're almost like too easy. B and G, B is negative 2, 0. G is 2, 0. I'm probably just going to blow through the rest of these. We get negative 4 plus 0, which is negative 4. Okay? It's like negative work being done. We're going in opposite directions, bounce off each other kind of thing. S and W. I don't even see an S and a W. Okay. Yeah, skip this one. 2b minus 4a. All right, if you're multiplying by a scalar, you just multiply both of the components. This is like the easy stuff. So it's 2 times 2 comma 0, and then subtract 4 times 0 comma 2. Again, like we could show what the visual of subtraction looks like. It like if you take the two vectors, it ends up being like split in between them. It's not important though for you guys. Might be important if you end up in the physics world. But look at that. Since B and A are perpendicular, they're orthogonal. B is negative 2, 0. A is 0, 2. 0, 2. Since they're 90 degrees, I know this is going to be 0, but I can confirm 4 times 0 plus, oh, wait, I'm not dot producting them. I'm subtracting them. 4 minus 0 is 4. 0 minus 8 is negative 8. Okay, so boom, boom. That's component form. Um, Dot products are scalar. Addition, subtraction. You can also put that in the other form. Find a unit vector in the opposite direction of C. C's at 2, 2. I mean, this is pretty easy. Like 2, 2. I wish this was a little bit harder. I wish it was like 3, 4. So I'll do both. Because I can kind of just figure out 2, 2. Here's 2, 2. You want to go in the opposite direction? But it needs to be a length 1. It's not that easy, actually. It's not that easy. Well, first thing to be in the opposite direction is like both of our components need to be negative. That's good. Um, what's the magnitude of this? Let's see. This is 4 plus 4, which is 8. So the magnitude is root 8. How do you make a unit vector? We dilate, divide everything by root 8. So 2 over root 8, 2 over root 8, which we could probably simplify. 2 root 2 2 root 2. Oh, yeah, this is great. This is great. This will be 1 over root 2, which will be root 2 over 2. Oh, look at that. Those are your familiar side lengths of a 45, 45, 90 with a hypotenuse of 1. It's fantastic. But we're going in the opposite direction, so these need to be negative. Uh, that was fun. Now, if you were going to do it with like 3, 4, you take 3, 4, make it a unit vector, dilate, divide by its magnitude. Magnitude is 5. You could find using the Pythagorean theorem. Turn that into a unit vector of 1, divide by 5, 3/5, 4/5, and then put it in the opposite direction. Find your vector of length 6 in the direction of f. This is like another good, and this is like a good next step for projection vectors. Because f is like, F's a good example. F's a good example. So f is negative 2, negative 2. And that's here. Okay? Now, its magnitude, again, is root 8 or 2 root 2. Now, I want a vector of length 6. What do? It's like a procedure. We first find our unit vector. So a vector of length 1. How are you going to do that? Divide by the magnitude. And then what are we going to do after that? We're going to turn it into a vector of length 6. It's easy to do that. Just multiply by that magnitude. This is what we do with projection vectors. We take our vector, divide it by the magnitude, we get our unit vector, then we multiply it by the magnitude of our projection, which we get from the dot product. It's like, A cosine theta, or it's like dot product over magnitude of B. So I have, after some simplification, negative root 2 over 2, negative root 2 over 2, and then times 6 gives me negative 3 root 2, and then negative 3 root 2. If I square that, I get 9 times 2, which is 18. 18 plus 18 is 36. Square rooted is 6. Boom, checks out. So this is it. You should be able to do that with any vector, like 3, 4. Take it, make it a unit vector, multiply it by whatever size you want to get as well. All right, great. I don't like these simple numbers, but it's fine. Finding angles between vectors. There are 2 different ways that we will be able to do this. You pick the way that suits you best, but you will not be given the specific formula to find this. You got ij, which is just 1, 1. Oh, gosh. This is like kind of, maybe it's not that easy. And then you got 2, negative 2. Okay? Find that angle in between them. This would be a little bit different than some of the other ones to do. But here's probably what you're used to if you did the homework and you followed the formulas. Use this guy. I can't copy and paste that over, so I'll just write it out. Here's the formula. We got a formula for dot product this way equals dot product this way. Okay? We could decide to solve this for cosine theta and then take the cosine inverse of both sides, which means like, let's find the dot product this way. Oh my gosh, it's going to be 0. All right, fine. I hope the other ones aren't so simple. 1 times 2 is 2. 1 times negative 2 is negative 2. That's 0. Guess what? If your dot product 0, what's going on? You know immediately. Like if you divide by the magnitude, it's still 0. Your angle's 90 degrees. You're what we call orthogonal. There's the other way, and let me show you the other way. It's like, let's find the individual angles and then manipulate them to get us. Like I could tan inverse 1 over 1 and get 45 degrees. And I could tan inverse -2 over 2 and get -45 degrees. Add them together, you get 90. I don't like how we're sticking on these 45 degrees. This is better. Here we go. Let's just take this one. Make sure you can do this one by yourself. The other one just is neat and stuff, but kind of obvious. All right, ready? We got 1, 7, and we got -2, 4. This is a good one. What is this angle in between them? Okay. All right. We could have dot product one way equals dot product other way. Solve for cos theta, cos inverse both sides. Let's do that. Let's find the dot product using the components. -2 plus 28 is 26. Okay, 1 times -2 is -2. 7 times 4 is 28. And then magnitude of A. Let's find the magnitude of A. It's 49 plus 1 is 50, so this is root 50. The magnitude of B is 4 plus 16, which is 20, so that's root 20. Cosine theta. Solve for cosine theta. I got 26. Oh, that's right. Yep. Over root 50, root 20, which is root 1,000, I think. And then I'll take the cos inverse of both sides. You develop the formula because you're smart. Make sure you use parentheses if you're going to do these. Use alpha F1 if you're going to do these. Or just be careful, please. Okay. Cos inverse that, make sure you're in degree mode. 34 degrees. Okay. There's one way. I'm going to go ahead and check my answer. I was like, maybe I don't feel good about that. All right. Watch this. I'm going to find this angle. There. Using tan inverse. Tangent theta equals 7 over 1. And then I could either find this angle, but I probably want to find that angle. And then I'll subtract the 2. There's other ways that you can do it, I'm sure. But I'm going to keep it simple, so I don't have to think too much. So let's find the blue one first. All right. So, blue one. Tan theta equals opposite over adjacent. I got tan theta equals -2. I'll take the tan inverse. I'm in the second quadrant, though. That's important. Tan inverse, -2. Boom. I know that's not my angle. That's in the fourth quadrant. I take 180. I add that. Okay, that's my blue angle. 116. Let's find my red angle. This is in the first quadrant, so we're good. Take the tan inverse of 7 over 1. Boom. Now, if all is right in the world, when I subtract these two, I should get 34.695. Or else a mistake was made somewhere, and I will feel bad about myself. Booyah. Okay, so options. Checking. Check your work by doing the other method that you didn't do the first time. Okay? I don't love these questions. Because again, we're using like 2-2, but I'll just show you what they are. A. Now, is it in standard position? No, it doesn't matter. Like, what do? You don't go left and right at all, but you do go up 2. So A's components are 0, 2. I'm going to multiply that by 4, add some x, and I get 5c. Well, C's components are over to the right 2, up 2. So I don't care that it's like this, there's no like origin, right? It doesn't matter where vectors are located. It's all about their x and y components. So this gives me 0, 8 plus some vector gives me 10, 10. So 0 needs to become 10, 8 becomes 10. You could kind of figure out subtract or do whatever you want. X's vector must be 10, 2. Or, you know what you could have done? Like subtract 4a. Subtract 4a. So this minus 4 times that. It's the same thing. Whatever. Uh, W is, again, just like A, they're the same. W and A are equivalent. W is 0, 2. So multiply that by 5. Scalars, you just multiply each one. It's easy. Negative 3c. C, we just talked about, is 2, 2. So multiply by negative 3. Negative 6, negative 6. Okay. Dot products. More dot products. It's fine. There's multiple ways to do it. They are giving you the component form, so it's easiest to do x1, x2, y1, y2. Okay, this is easiest. Sometimes it's easier to do magnitudes, depending on the situation. If you are asked to find the work, work is the same as the dot product. Sometimes work is easier to find using the component method. Other times it's easier to find using the uh, magnitude method. Component method for A and B, though. 2 times 7 plus 5 times negative 3. 14 plus negative 15, negative 1. C and B, negative 4 times 7 plus negative 3 times 1, negative 28 plus negative 3. It's like kind of things are getting bounced off in the opposite direction. You're doing negative work. They're not helping each other, these vectors. That's the idea behind dot products, is like how much are they boosting each other, helping each other? How close are you to accomplishing your goal? You know, how much do you have to do? D and F, three-dimensional dot products, no big deal. 2 times 4 plus 5 times 0 plus 3 times 7. It's just components plus components plus components. 29. That's boost. Those are vectors helping each other. That is positive work versus negative work. Uh, Orthogonal. Now it's like coming up with an orthogonal vector. Not not maybe that easy to like think of because there's an infinite amount of orthogonal vectors. You could do whatever you want. Like I could say orthogonal with a x component of 3. And I ask you like what's the y component? You know, I could ask that. You can do whatever you want. You can just figure it out. But what is the key to being orthogonal? The x components and the y components will cancel each other out, and you will be doing no work at all. You will be making no progress. You will not be shutting the door because you'll be pushing up when the door slides left and right. That's the idea. I could find it here. So negative 4 times 3 plus 1 times y has to equal 0. 0 work, dot product, perpendicularness. That's so important. So y is 12. Okay, that's easy. What's another one? I mean, it's kind of easy just to think of, here's the perpendicular. Putting 1 here, so I'd have negative 4 times 1, that's negative 4. So what do I need? A positive 4. So it'd be 1 times 4. There you go, there's another one. You can do whatever you want, okay? You can pick a y coordinate and find the x. But what's the key to being orthogonal? Dot products equals 0. And you ask Mr. Huffaker, what's the most important part of this lesson for your future? Is this. All right, vector projection. Here's how I do it. I don't have the formula memorized. You will be given the formula, but this is how I do it. Okay. I start with a picture. I got A and I got B. I read things correctly. I'm projecting vector A onto B. So A is getting projected onto B. Now, what do I see here? A vector that's going in the same direction as B. Okay, so what do I need? To find that vector by taking vector B, making it a unit vector. We've been doing this, dividing it by the magnitude, then multiplying it by the magnitude I want. Now, this is where it gets complicated. Dot product, we said, is like this idea right here. This is where dot product comes from. It's like, how much is one helping the other? Well, you would say it's like I got B's magnitude here, and then I got the projections magnitude here. Turns out, like, this is the start of the dot product formula. You started with this, and then you realize this projection of A onto B ends up being that vector A times the cosine of theta. And you could use that. A times the cosine of theta is the projection of A onto B, its magnitude. But what we end up using is the fact that I can solve this for the projections magnitude. The projections magnitude is the dot product divided by the magnitude of B. And that's what we use. And that's what I'm going to give you is this formula for projection. Should I give it to you? Yeah, I should probably give it to you. I probably should have just, I don't know. I'm fine with this. Okay. So I don't have to go back and forth. B is 7/3, 7 negative. The magnitude of B is 49 plus 9 is 58. Root 58 would be the magnitude. The dot product of A and B. So A is 2, 5, and B is 7, negative 3. So I got 14 plus negative 15, which is negative 1. Okay, cool. Which means they're not really helping each other out here. And they're close to being at a 90-degree angle, but they're not. B's magnitude, root 58. That actually helps with the calculations. So we end up taking the vector 7, negative 3, and multiplying it by negative 1 over 58, giving me something, and you could like plug this into your calculator, see if it simplifies. I don't think it does. Negative 7 over 58 and 3 over 58. Boom. There's the projection vector. B onto A. Okay, so if this is B and this is A, and I'm projecting B onto A, we're going in this direction. B is being projected onto A. This is not the right picture. It'd probably be longer than this. But what do I got? A's vector at this length. Make it a unit vector. Multiply it by the projection's magnitude. Projection's magnitude is the dot product divided by the magnitude of A. It comes from this guy. It's like, what is going on? A's magnitude times the projection of B onto A. If I want this magnitude, dot product divided by A. Works out. A's vector is 2, 5. A's magnitude would be 25 plus 4, which is 29, root 29. You can square that. That's in the formula that we used on the homework. Dot product I already did was negative 1, root 29. Here they go. They're going to cancel school for the rest of the week.
Pardon the interruption, you guys. I wanted to go ahead and let you guys know that Route 39, 40,
Sorry.
51, and 52 have been canceled. Once again, that's Route 39, 40,
I'm sorry.
51, and 52 have been canceled for after-school transportation. Please take a few minutes to make sure you contact a ride if you need one. Thank you so much. Have a good day.
Yeah, not very nice. Marble Falls canceled classes tomorrow. I honestly think we should cancel classes. I've been like, keep the kids in class, keep them at home, but like, there's too many kids out. It's crazy.
What? How many? Like, what percentage of your kids are out? Do you think?
I think we're pushing 20% now. Yeah.
Wow.
My teacher couldn't teach today because we didn't have enough students.
Ugh. I mean, I'll always teach, and I got videos, but it's just tough for kids at home. I know. Yeah. All right. E on to D. E on to D. E on to D. E on to D. We're going in the direction of D. So I'm starting with D. Make it a unit vector. Give it its magnitude by taking that unit vector and multiplying by the projection's magnitude. E cosine theta is one way, or dot product divided by D, which is a little bit easier. All right, D's vector is 2, 5, 3. D's magnitude is 25 plus 4 plus 9, which is 29 plus 9 is 38. So 1 over root 38. The dot product between the two, 2, 5, 3, and negative 1, 2, 1, is negative 2 plus 10 plus 3, which is 11. And then this repeats itself, which is why we get this stuff squared. So we just have 2 times 11 over 38. We have 5 times 11 over 38. I'm not going to bother simplifying those. You can do it with your calculator. 3 times 11 over 38. Project E onto F. Great. So E onto F. We're going in the direction of F. So we start with F. We make it a unit vector. We then give it its proper magnitude. Easiest way to find that is the dot product divided by F's magnitude. F is 407. F's magnitude is 16 plus 49. Oh, gosh, I can't think anymore. 65. So 1 over root 65. Make sure we take the square root. The dot product of E and F, negative 121 and 407, is negative 4 plus 0 plus 7, which is 3. So these vectors are helping each other out, but not much. Root 65. Not pretty. Sure, simplify. 12 over 65. 0. 21 over 65. When will these be orthogonal? Well, when the dot product equals 0. Oh, look at that. We don't even need a calculator. When sine negative a half, that's when I'm going down. Well, sine's a half at the shorter 30, 60, 90 triangles, right? So that's at the pi over 6s or the 30 degrees. But I want the 30 degrees when I'm going down. The 30 degrees when I'm going down is this 30-degree angle and this 30-degree angle. So the two of them would be 210 and 330. Don't line up by the door. We have too much time. Just wait till the bell and just bolt your way out of it. Like, be ready at your seats, and then when the bell rings, you get out of here. But don't line up by the door. If you're given magnitudes and dot products, can you find angles? Yeah, because you have the formula. The dot product equals magnitude, cosine theta. The dot product's negative 93. The magnitudes are 20 and 6. This is what you would have to do anyways. Like, you won't get the formula. Negative 93 divided by 20 times 6. You guys are the closest ones to the door, too. This is a new experience for you. You don't understand how much time you save by being in the C0 level. Take the cos inverse of both sides. 140 degrees. That looks good to me. All right. To the final two questions that are work. Work is the dot product. There are two ways to calculate the dot product. You could decide to split things into components x1, x2 plus y1, y2. Boom, that's one way. But another way is to do magnitude times the cosine of the angle in between them. My friends, this first question, you can think of the force 25 as a magnitude. You can think of the 50 as a magnitude. It's so simple. Magnitude times the cosine of the angle. Boom, I'm done. That's my answer. Don't do anything more because you don't need to. Type that into your calculator. I know you guys don't like doing this, but this situation, it is not advantageous for us to use magnitude, cos angle because of the following. We have this force applied at an object of a 25-degree angle. It's not obvious, but the 25-degree angle is with the horizontal. But the displacement that's occurring is not going horizontal, it's at an angle. So if you want to do magnitude, cos angle, take some work. Instead, what you can do is break this into x and y vectors. Okay? An x component and a y component. And then you can dot product x component, y component, y component. All right, get out of here.
Adios.
Yeah, I'll see you next year in AB Calculus if you take it. Just AB. Huffaker teaches BC. Yep, have a good one.
Thanks so much.
Yep, have a good one.
Is it possible to get the homework back, or just because I used it to study for tests? Can you write down, like, take a look at and write down actually the homework or something? Okay, oh, just take a photo. I'll take a photo.
That works. So let me walk you through that again, because I'm not getting out of here before the bell. The angle, 25 degrees, is actually with the horizontal. But then the block is like shifting at a different angle than that 25 degrees. It's not going with the horizontal as well. It's tougher to do magnitude, cosine angle in this situation. You could. Here's some work to do it. But instead, what we should do is turn this into components and then dot product them, because that's easier. Dot product using xx plus yy. That's going to be easier to do. Now, to do that, we know this angle is 25 degrees. Okay, r cos theta, r sine theta, just like polar. Cosine of theta equals x over d. D cos theta equals x. Pythagorean theorem. Do you want me to show it? Sure. Cosine of 25 degrees equals this x component over the hypotenuse. 20 cos 25 equals x. Okay? 20 cos 25. There's my x component. 18.126. Hold on to that entire number. We're going to do the same thing with sine, the y component. The sine of 25 degrees equals y over d. 20 sine 25. That's my y component. 8.452. Okay. Dot product. What's going on? Okay. This times 10 plus this times 2. That's the work, 198.166. I will show you the other way to get that work using magnitude, cosine angle. This is 20, right? What's this magnitude of this red vector? Well, square root of 10 squared plus 2 squared. So square root of 104. But the angle between them is not 25 degrees. It's not. 25 degrees is the horizontal to this. What I would have to do is find the angle here of the red vector, of the 10, 2 vector. Could take the tan inverse of 2 over 10. Boom. That's the angle right there, which means the angle between them would be 25 minus that angle right there. 13.69. Watch. Magnitude times magnitude times the cosine of that angle that I just found. I'm going to get 198.166. Okay? That, my friends, is vectors. Let's do well on the test.